Okay, welcome everyone to my first video, Practical Fuzzing Basics using the Sulley framework. This is the first video of hopefully many more to come, explaining to you the whole process from fuzzing an application to getting a working exploit. To do so, I will pick suitable exploits from the exploit database and recreate the exploit development process. The first few videos might be slightly longer to explain the basics you need to know to understand the later videos. As this is my first video, some background information about my person. I currently work as an information security auditor in Munich, Germany, so I'm not a full-time exploit developer. Before that, I worked in the field of IT forensics and as an incident handler. If you want to know more about my background, just visit my website www.defate.de and or go to my LinkedIn profile. So, for now, I want to dig deeper into the topic of exploit development, and by creating these videos, I follow the approach of learning by teaching. So let's see if it works out. As a prerequisite, if you want to follow this tutorial, you need to download the Sulley framework. You will get it on their GitHub website, and if you scroll down, there's a nice article about how to set up Sulley in a Windows environment. Here a quick overview about the technical requirements for this tutorial. You will need 2 Windows machines, a fuzzer, let's say a fuzzer attack machine, and a fuzzer target or victim. On the attack machine, we will run our fuzzing attack script, and we will run a network monitor to monitor outgoing traffic we send to the vulnerable application. On the fuzzing target machine, we will run a process monitor to monitor our vulnerable application, and in case the application crashes, this process monitor will dump the relevant memory and will then restart the process. One minor detail, by default the process monitor will communicate with the attack script on TCP port 26002, so if there's a firewall in between or there's no connection, you will get some error messages in our attack script. Okay, let's pick a suitable application to start with. Let's go to the exploit database, and I've chosen the PCMan FTP server because the FTP protocol is quite simple, so it's easy to write a starting fuzzing grammar, and it has the vulnerable application to download, so everyone can follow this tutorial. I don't want to read the details of this exploit because this is what we want to figure out on our own. So if you want to follow, just download the vulnerable app. I won't do it because I already did so. Prepare a victim machine, in my case it's this Windows machine, and install the PCMan FTP server. So if we start it here, that's the server listening on this IP address. To write the proper grammar, let's just create one legit connection to the FTP server, and we will use this connection as the baseline. So for now I will start Wireshark. I'm just focused on TCP port 21. And let's start creating FTP connection to our target system, present a username anonymous, present a password test1234, and do a directory listing. So we can see here on our victim machine that we are logged in as anonymous, and we see some traffic in Wireshark, which is good. If we follow the TCP dump, we can see how a normal connection would look like. So first we get the banner from the FTP server, then we send our username, we send our password, and there's the rest of our directory listing. Okay, let's close this connection. And we will still follow the TCP stream for later use. Okay, now for you to double check if the Sulley framework was installed correctly, the folder should look like this. And to double check if all dependencies are met, if you just start the process monitor and it comes up without any dependency issues, same with the networking monitor, you know that you installed it correctly. Okay, let's start writing our Sulley script. I would have two different versions, a simple one and a slightly more complex one with some added features. Let's start with a simple one. So in general, how does such a Sulley script look like? First of all, we have to import the Sulley library. So from Sulley, import everything. A general overview. First, we will have a session where we create the requests, like defining our fuzzing grammar Sulley should use. Then we will define our whole session, so put the requests in the right order and give some environment parameterization. Then we will define our target and we can start fuzzing. So let's just jump right into our first block of code. Our first block, we will start with the s_initialize command. So this is like a naming tag for this block. In our case, we name it user. You can name it however you like, but I would recommend to name it something you can identify easy, because later on you will just see this naming description, and it's better if you know what is happening in this block. Next, we will define a static string we will send. So just as a reminder, if you follow the stream, we send this user. You could also already fuzz this command, but in my case I don't want to do it. I just want to send a static user string. Next, we have a delimiter, which is a space before we send the anonymous. What you can do, I don't do this in this example here, you can also mutate or fuzz a delimiter. So here it's just a space, but if we set the fuzzable to true, it will add a tab, carriage return, a lot of spaces, and so on. If you are interested what happens in detail, I would recommend you go to the Sulley folder, open up the primitives Python, and just search for the class delim, for example. So we end up here, and you can see this is what happens with the delimiter. So our space will get doubled, it will get reproduced 5 times, 10 times, 25. There are some other delimiters added, and that's already it. Next, we will add a string, which in our case is anonymous. A string will have way more mutations than a delimiter. Just to show it to you, we go to the primitives again, we search for the class string, and you will see that we have way more or way different values we will put as a string here. Feel free to add new mutations here or to fine-tune it as you like. Next, we have once again a static value as a carriage return, so that we send this information. If you want to get more information about these commands, or you want to figure out what other commands exist, because there are way more than these, I would recommend you go to fuzzing.org and you can first check the manual. So it's just around 29 pages. It's a very quick read and it will give you a very good basic understanding of the Sulley framework. Or you go into the API docs and you will find all commands explained here as well. For example, let's take the initialize. So here, initialize a new block request, and when you click it, you will see what parameters you can set, and you will find out that there are way more than I will show in this first example. Okay, after we define the first block, we will define more. So we already have a user, and now we will define, if you look here as next, a password block. So here we initialize a new block, we will name it password, and the rest is pretty much the same than the user block. After the pass block, we just want to fuzz some additional commands you can use in an FTP session. For example, put, store, and make directory. We just changed the string here, but it's really not that relevant what kind of string you will put here. The rest, these commands will stay the same. So once we have created the request blocks, we will define our session. To do so, I will go down here. We have some basic session parameters we want to set. So we will define a session file name. In this case, it's pcman ftpd minus session. In this session file, Sulley will track the current state of the fuzzing session. So if for any reason you want to stop the current fuzzing session, or your system crashes or whatever, as long as you are in possession of that file, you can just continue wherever you left the last time. But please also be aware, if you start multiple sessions and you don't change this name and you still have a session file, it will start at the last state where you stopped. So for example, let's say you just ran through the whole fuzzing session. The file will be there, you change some values and you want to fuzz again. It will be finished directly, because it will look into the session file and it will figure out that it stopped at the end, and it won't try anything new. So please always be aware if there's a session file and if you want it there. Next, we will define a sleep time. This is a pause between two fuzzing requests. So we send our first username and a mutated string. We see what happens, and then we wait half a second to start the next request. Then we have a timeout value. So after 5 seconds of no connection to our fuzzing victim, our fuzzer will stop because it knows something is wrong. And we will define a crash threshold of 4. What is this value? Let's jump to our first block. So here we will send different fuzzed usernames anonymous, because the rest is quite static. So let's say we already crashed this application when we sent a username of 5,000, or let's say 5,000 A's. And we crash it again with 5,500 A's and 6,000 A's and so on. You get the picture. It doesn't make sense for me now to test all these mutations. If it crashes at a lower value, why should we try all the upper values? So we say if this application during the user block crashes for 4 times, we want to stop and we skip the rest of the mutations and we jump to the next block. There might be some cases where it makes sense to get more crashes, so you just adjust this value accordingly. So we define the values here. We will add it to our session, and we will now put these blocks, these request blocks, in the correct order. To do so, we start with this command. We created our own session. We connect the user block. So it will then mutate everything we defined in our user block. Once it's done, it will go to the next session, which will start with a username and then with a password, because it doesn't make sense to connect to an FTP server and the first command you issue is a pass command. It will say that it's a wrong command and it will just close the connection. The Sulley framework is clever enough to realize that the user request block was already fuzzed, so it will just send the default values you defined here, which will be the username anonymous, and then it will mutate the password block. Once this is done, we want to create a new session. We want to get to the store block. To get there, we first have to send the user block, the password block, and then we jump to the store, make directory, or put block. Sulley, once again, is clever enough to see if we start with a password block, it knows that before the password block we have to set the user block. How this will look like, we will put in a graph that is written here. So we will open a file, we will render a graph to show this workflow of Sulley. And let's do it right away to show you and get a better understanding. We start the pcman ftp simple. We'll get asked if you want to continue, we say no. because nevertheless the graph will already be created. So we have the session test, and if we open it here, you will see the workflow of the Sulley fuzzing session. So it will start with the user, then there will be a password fuzzer, and then store, make directory, and put. To open a UDG file, there might be several applications. I've chosen udraw. It's created from students of the University of Bremen, and you can download this application on that website. Okay, now I skipped this one line. There's a present method you can use. So let's say you have a more complex protocol or a more complex application, and before we get to the parameters you want to fuzz, there's some communication in advance that has to take place. With the present command, and we have the receive FTP banner function here we just wrote, we define a function that takes place right after the three-way handshake. So once we have sent the syn egg, this function will take place. In our situation, we will just receive the first banner, which is this one, and then we will start with our fuzzing session. Next, we have to define the target. So in our case, we define the target application. It will listen on this IP address, that port. We will define where we can reach our process monitor. So it's once again the same IP address, and it will listen on 2602. And we will connect to our network monitor, which will be running on our local system on port 2601. For the process monitor, we have some more parameters we have to set. We have to set the process name, which will be pcman ftpd2.exe. We will define a stop command. So if for some reason the application hangs but not completely crashes, we will use this command to completely kill the application, and we use the start command to start it again. Next step is we add this target to the session we defined, and we can already go to our last step right now, which is use the fuzz method to start fuzzing. Okay, let's now prepare everything for our fuzzing session. We don't need this anymore. Let's first start the network monitor. As you can see, there are some parameters we can set. So first we have to define the device it should listen on. We will set a filter to just focus on the traffic we really want. We will define a log path. This will be the path where all the PCAP files are stored. We can define a log level, and if you want to change the port, we can use the port command. So in our case, we will listen on device 0. We will filter for port 21, and we will write everything to the audit folder. Let's see if everything is correct. Okay, so the network monitor is running. Now let's start our fuzzing script, pcman ftpd simple. Number of mutations. So here I skipped this in the script because it's just for some additional overview. We will use the s.num mutations to enumerate all mutations for our first request block, and then we will multiply it with 5 because all our blocks here are the same, so we can just multiply it by 5 because we have 1, 2, 3, 4, 5 request blocks. So we get a total number, and then we will get asked if we want to continue or not. Why do we have this check? By looking at this number, we can already figure out if our grammar is, or if our basic definition is correct. So if this number would be way too high or way too low, we would be able to figure out, okay, something is wrong. Maybe we should have another look at our fuzzing script again before we continue. Why do we want this this additional check? Sulley doesn't really react pretty well to Control-C, so you can't see it, but maybe you can hear it. I'm pressing Control-C right now, and nothing stops. So before we start our script, we want to make sure that everything is correct. Okay, In our case, we say, let's try. So it will run the script and it will try to connect to the process monitor. And it will fail because we haven't started it yet. But let's just do so now. And for now, we will stop this. Here you see once again we defined the process name in the Sulley script. This is the name we have here to double check if it's correct. We will stop it. And let's start our process monitor here. What kind of options do we have? We will define a crash bin file. This is where the memory dump information will be stored. PCMan ftpd underscore crash bin. We will have the process name that it should monitor, which was PCMan ftpd2.exe. We can, if we have multiple instances of this process running, we can ignore a specific process ID. We can define the log level. I will just keep it as a default. And we can change the port 2602 to something else if we wanted to. Okay, let's just start. And now we have the process monitor listening. We see we have a connection from our fuzzer. And let's start our network monitor again here. Perfect, so it will now start the fuzzing process. You will see that the PCMan ftpd server will be started. And let's just watch if something happens. It will get 5 seconds to start, and we already have our first crash. So after a crash, once again, we get 5 seconds to settle in, as it is set here. Here you can see our fuzzing attempts, and here you can see the pcap files that are written. One interesting thing we will see here quite fast, we did define a crash threshold of 4, so after 4 crashes in one block, it will skip the whole block, in our case the user block, and it will jump to the password block. Let's see if we can figure out if this behavior here. So you see crash threshold reached for this primitive, exhausting 1063 mutants. So it will now jump from the user to the pass block. Okay, to get a better overview of this, once we start this fuzzing script, it will start a minimal web server showing you the current state of our fuzzing session. And it will look like this. I will just reset it. That was from a previous session. So here you can see that the user session is finished already. You will see the total number of mutations. It won't refresh automatically, so you always have to resume. So you can see that we are now in the password block. We are at mutation number 10 of 1074, and if you resume, you will see we get more and more crashes. Also, you can see these are the test cases. This was our 4th crash, so you will see we skipped around 1065 more primitives, and we jumped here to this. Oh, it was 1063, but we will just see the test cases where a crash occurred. If we click on the test case, we can see the output of the memory dump. So here you can see that we already overwrote EIP with some A's. Here we have the different registers, but how you read this in detail I will explain to you in the next video. So while this is running, it should just be about some minutes, because the crash threshold for each block, we are already in the store block, is reached quite fast. I will show you the slightly more complex script I wrote. So the skeleton is the same. I just added some kind of a debugging function. What it will do is it will write down all mutations to one file, which is named PCMan all cases txt. It will help us later on when we just have the case numbers and the pcap file to figure out exactly what information was sent. And I will just run it right now to show you, because it will not interfere with our currently running fuzzing session. So I will go into the fuzzing folder, Sulley, Python, PCman, FTPD. So here, do you want to just generate use cases without sending any traffic? I say yes, I want it. It will show us for each single request block how many mutations we have. And if you look here now, we have the all cases file, which is already, just these few mutations already blow up this file to be 356 megabyte. So it might be still usable in this case. If you do way more fuzzing, this might be a function you don't want to use. Just a personal recommendation, if you want to have a look at huge text files under Windows, Notepad is not the best program for you because it crashes quite easily and might load a very long time. I can recommend the Mandiant Highlighter because this program is really able to digest even very large files. Just to give you an example, let's load it. And here you can see really what our Sulley fuzzer is sending to our target application. And here you can easily see the single blocks. So this is our user request section, the password request sections, and these are the other sections. These use case numbers will be important for us later on, as you will see. Okay, let's see how far are we with fuzzing. We're already at 80%. We are at the put block. This should be our last block. And yep, we already reached the crash threshold and we are done. Let's double check on our victim machine. The process is running and nothing is happening here. So we now come into the phase of postmortem fuzzing analysis. To do so, we go into the fuzzing folder and we will copy the crash bin file. The crash bin file is the file where the process monitor is stored or the memory dumps. We will copy it to our tag machine. Okay, let's stop this. So we have our PCman FTPD crash bin file. We will put it into our fuzzing Sulley folder. And now we have several utilities that will support us in getting rid of all the valid connections and just filter out these connections that led to a crash. Because if you look here into the audit folder, we will see a bunch of pcap files. These are all network connections, no matter if they led to a crash or not. And if you go to the utils, we have the pcap cleaner. This is the program which will help us get rid of the unnecessary pcap files. And we will have the crash bin explorer to look deeper into the memory dumps. Because right now we still have the web server, but once you close the fuzzing process here, this web server will no longer be available to you. Yeah, let's just start doing it. So get rid of these two processes, because Control-C won't work, so you have to end the process like this. We open it again, and as you can see, the processes are stopped, and if we refresh our web server, it's gone. Okay, let's just take this one. So what can we do with this? With these utilities? Let's start with the Process Explorer. It's the Crash Bin Explorer. As an argument, it wants to have the PCman FTPD crash bin file, and it will show us, okay, these use cases led to a crash where we overrode EIP with ACE. Here we have the use cases 11, 3233, 4307, where we overrode EIP with this value. So it's sorted by overridden values. If you want to see more details about one specific case, let's say for example the 2, we do the -t2 and we can see the memory information. So next we will use the utils pcap cleaner. This program wants to have the crash bin file because it will take these use case numbers and it will clean all pcap files that do not contain this use case numbers. Just be careful. To give you an example, so it will take this use case number 2, it will look for 2.pcap, it won't touch this file, but it will touch the other files. If, for example, you have a folder with additional files, like important data text file, it will also delete this text file. So it will delete everything except the pcap files that are necessary. So let's provide the crash bin file and the audit folder and shoot. And as you will see here, it will get rid of everything except the pcap files that are relevant for our use cases. And let's just open one pcap file to give you an example. Follow TCP stream. So we received the banner, we sent a quite long username, and we did not get a reply. So apparently the server already crashed, and if we look here into the dump of process number 2, we can see that our username consisting of a bunch of A's already overrode EIP with the A's. Now I want to show you something custom I added. It's just something quick and dirty, but I found it quite helpful. In this case, I added a new file called filter cases. And I just added some custom code to the crash bin explorer. Let's start here to show you what this custom code is doing. So I added an extract file name, which I call PCMan relevant cases. And I added some code here. All it does is it takes the ID numbers you can see here and puts it into one separate file. With the next quick and dirty script, I will just take these use case numbers. I will read the file with all the use cases, and I will just filter out the use cases I'm interested in. So it's even more easier or convenient to see what kind of information was sent during the fuzzing process. And let's just do it. As you can see here, the PCMan relevant cases was already created. So here we have the IDs. And if I now start the Python utils filter cases script, just take some seconds. As you can see, PCMan relevant txt was created. It's way smaller, and if we open it, you see, okay, during use case 2 we send a bunch of A's. In use case 3 we also send a bunch of A's with a different starting character. And as you can see, we are always in the crash threshold of 4. So after 4 crashes, it jumped to the next request block. Okay, that's it for our first fuzzing session. In the next video, we will start here and we will go into the exploit development process. I hope you enjoyed the video. Please give me feedback if you liked it, what I can do better, or maybe if you fine-tuned some scripts. Please let me know, and I would like to take over your changes. Okay, so bye bye. See you next time.